Hello and welcome back. We are going to go ahead and pick up where we left off with interfaces. We just have a little bit of interfaces stuff left, actually. It's not too bad at all. I'm going to go ahead and make this a little bit bigger, make sure that my screen sharing is still good. Awesome. So we're going to just talk about some very specific scenarios here now for using interfaces and using the power of interfaces to implement our code. So, really quickly before I get into this next example, we have already last video, let me start over. Last video, we talked a little bit about what an interface actually is, how we can use the keyword interface to define it instead of the keyword class, how we have the implements keyword when we actually want to take a concrete class that's going to implement the interface, how interfaces have basically just a bunch of method headers without the word public listed, and then any class that implements that interface has to implement all the classes that we give it. And we started to see some of the power of that when we talked about using array lists and making an array list of objects where that object data type was our interface. And that was a thing we were allowed to do. Now, while we can't make a new instance of our interface, we can declare variables of that type. And by doing so in a situation like with an array list, we end up with this ability to kind of mix and match objects almost. So we can mix and match objects that maybe seem a little bit different from each other, but still close enough to being the same that they can all kind of be stored together. So as part of this video, before I start going into this example, actually, I think I'm gonna just give one more coding example here, just because interfaces can be so tricky to follow, and I want people to feel like they have a really good basis for this. So we're gonna look at, if we look at this, it says we're gonna check this student list interface.zip folder to see this. So I'm actually going to start with a student list interface example so that we can build on it with the rest of the code. So this will be our folder. I'm going to go ahead and open it up, and I'm just going to make a couple of starting classes to get us going. For example, we're going to make a student.java. Actually, we're going to make an undergraduate student.java file. And so public class undergraduate student. And undergraduate students are going to have names, and they're also going to have a student number, and they will also have a, pardon me, a GPA, let's say, just like this. And we'll make some, are we going to need any getters right now? Let me think. I want to think about what I want to do with this. Okay, we'll make the constructor first. Student has a name. A student has their student number, and we'll just pass all the information in for now. That's fine. And this dot GPA is equal to GPA. I'm not even going to make a toString yet. We're just going to hold off on that for right now. We're going to leave it like this. Something I want to do first off now is I think I want to actually make some kind of interface for like iStudent.java, and this will be our interface for our student information, so that we can do things like get the GPA for a student, right? We can get a student's GPA. We can print student information, and we can get a student number, get student number. So those are all things that we can do with students. So I've gone ahead and made that interface. I want to move this out of the way and make this a little bit bigger. Now we're going to go here. We're going to implement that class, implements iStudent. And now we're going to get some errors because we have to make sure we're actually implementing all of those classes. So here we can implement the get GPA method, which will literally just be the getter GPA. printing student information method is going to do a system.out.println of the student's name, followed by, we'll do it like this again, the student number in brackets. Actually, let's say undergraduate, and then we'll do a new line, tab, name, student name. No, I don't like that either. Name, student number, and then we'll just put down here undergraduate, just so that we have like the type of student that they are here. And then we'll get the student number here as well. We're not doing anything with the GPA yet. That's okay. We'll figure that out later. Oops. Yeah. So the next thing I want to do is I want to create another, whoops. I want to create another class. And I'm going to make a class called graduate student. And now graduate students, whoops, they also have a name. They also have, oops, I forgot string. They also have a student number. They also, oops, have a GPA. They also have like an advisor, like a staff member advisor, let's say. But they are a type of student, right? So since they are a type of student, we're going to, implement our iStudent one here and go ahead and implement each of those methods as well. So first we'll implement get GPA. So we'll return this student's GPA. Here we can print the student's information. I'm going to just copy and paste this for right now. And then in here, rather than printing the name and then their student number and undergraduate, we're going to say graduate. And we're also going to include on a new line, the name of their advisor, since they have one as a graduate student. Advisor, so we change this to graduate from undergraduate, and they have an advisor, so we're going to put that information out too. And then right here, we're going to also be able to just retrieve their student number if we want to. Okay, so now we have graduate students and we have undergraduate students. We're going to add one more class in here. We're actually going to add a few more, but we're going to add another class in here for advisors. .java, and an advisor has a name. They have an employee number, not a student number, because they work for the university. And they also are going to have like a list of graduate students that they are supervising. Students. Those are the I'll better put in a students under supervision. It's important to know that what that is, I guess. So, oh, and this is called graduate student. Okay, so now this will not implement the student interface because it's not a student, it's an advisor. And an advisor can have a name and an employee number by default. Like this. And then we'll say this dot name is equal to name, this dot employee number is equal to employee number, this dot students is going to be equal to a new array list of students, of graduate students. And there we go. And of course, we're going to need to actually be able to do something with this information so that this doesn't yell at us anymore. So maybe we'll just put a public toString in this one, just to have something here. It's not going to print all the information. I just want to have some information in here. We'll do it actually very similar to the print method from before. Return name. I guess this is the advisor. So advisor's name. And then we'll put their employee number in brackets. Like this. And we're not going to do anything with the students yet. In terms of printing, we have to be able to say advise new student. So a new student comes in. And rather than graduate student here, actually, I'm going to make this iStudent because we can supervise undergraduate students for projects too. They do all sorts of fun projects. So we can say iStudent there. We can pass some kind of student in here. Oops. And we can let them be a new student that we're going to advise. And now before we have any way of doing any sort of graduation of these students, I'm going to write that method, but I'm just going to leave it blank for right now so we can fill it in later. Graduate student, that looks like graduate. I better say student graduates. And we'll have to go find the student that graduates. And what we're going to do is find student that is graduating. If undergrad student, say congrats on bachelor's degree. If graduate student, say congrats on graduate degree. If student does not exist, say you are not my student. Okay, and then we're just going to leave this for now to throw a new exception, the one that says that the method isn't implemented yet. Method not, what is it called? What's the method called? What is it? Come on, I just can't remember. And it was just here, unimplemented, isn't it? Unsupported operation. Method. I can't believe I can't remember what it's called. I really thought it was like unsupported or unwritten method or something. Some kind of, isn't it? Warning? Oh my God, I can't remember. We're just gonna have to say not yet implemented, just in case we try to use it and we're not yet implementing it. Okay, so this is for the advisors. Advisors have a list of students. These are the students that are graduating. This is we forgot to put the name of the advisor in here, so that's great. That all looks much better now. We have graduate students, undergraduate students, advisors. This is awesome. Okay, so we're gonna do a couple things here. First, we're gonna test this and make sure it works. Then we're going to look back at the notes talking about collections, and we're actually going to turn this array list of students into a new class with collections. So let's just first test what we have here. Test, I better just call it main. Make it easy for when you read it later. We'll just call it main. This is where our main is going to be. And we are going to just make an advisor. We'll just use my name, make this really easy. I'm not an advisor of anybody, but we'll just use my name for now. That's my name. And we'll give me, whoops, an employee number. I probably should do some kind of error checking on that employee number, but for now it's fine. It doesn't really matter. So that will work. Then we should make a undergraduate student of some kind, US, new undergraduate student, animal is going to have a student number of whatever and a super high GPA. And then we're also going to have a graduate student, GS, a new graduate student. And this graduate student needs to take in a name as well. I hadn't gotten this far. Avril. And what else does a graduate student take in? Let's go look because I can't remember. Oh, I never even wrote a constructor here. So graduate students have an advisor. So I actually can make this into like an advisor like this. And we can say public graduate student. We're going to take in a name. We're going to take in a student number. We're going to take in a GPA. And in order to become a graduate student, you have to have an advisor assigned to you. So of course, we will just say advisor as well, like this. And then here we can see name, oops, this dot name is equal to name, this dot student number is equal to student number, this dot GPA is equal to GPA, and this dot advisor, whoops, advisor is going to be the advisor. And then we can also add the student to the advisors list. So advisor dot advise new student, and we can add this student to that list. So that's perfect. undergraduate students can exist without an advisor, but graduate students can't. So that's why it's like there's no real way to tie it back in that direction right now, but that's okay. So now we actually have this. We can give them a student number of some kind. We can give them a graduate student GPA, and we can give them an advisor. And so now when we go and we do stuff with this information, we can like print it out. We can make sure that these things are working as we expect. Now, we don't have two strings right now for undergraduate students and graduate students, but what we do have is that method that is going to actually print the student information that we made. So we're just going to use that for right now to make sure that all of our code runs according to plans. So if we go ahead and run this, we'll see it compiled, no problem. Here's the advisor, here's the student, and then here's this student's information where it includes the student and their advisor. So all of that worked perfectly, exactly as we expected. So that's great. We now are set up really, really well for us to go and look at collections so that we can figure out what exactly we want to do from here. So we've seen how we can use an interface type to describe the kind of object that we're going to store in some kind of a collection. So like inside an array list, we just did that. And collections themselves are frequently used actually to describe interfaces. And now this is really important, and we're going to see why in just a minute, because we can actually use an interface type to describe the kind of object as a collection as well, meaning that we can change a single line of code and use a totally different type of implementation, and it's a non-issue for us. So let's see what that actually means. Let's start by looking over here, and we're going to go and take a look at Java list interface. So we've talked about array lists, we've talked about linked lists, we've talked about arrays, we've had all these different things. And Java actually has a list interface. So this is actually an interface that has all the types of methods that are required to run properly. So when we go ahead and we use array list is actually inheriting a bunch of stuff from this interface. So let's fix our code first so that we're using a user-defined class instead of an array list directly. And then let's talk about implementing this list interface. We're going to do both of those things to make our code even more malleable than it is right now. So first, let's make a list of students, a student list dot Java class. And inside here, we're going to actually put our list of students. So here we had like a list of students. We're going to pick that up and change this into a student list variable. Student list, right? The advisor is going to have a list of students that they can do things with. And here, when they call add, they're going to be able to add that student to the list. Okay, so now let's actually go fill out that class with this. Whoops. Yep, that was right. Okay, lots of things changed automatically. But with this new list of students, so then when we say public student list, like when we make a new student list, we can go ahead and initialize that array list. New, array list of I students. And we, at this moment in time, just need a way to print out like one or add a student, right? Because we have public void add some kind of student to our list, student S, and then this will let us say students dot add S. Okay. We don't need array list here anymore. Now this takes in a student list. We run our code after doing that refactor. So what we did is we pulled student list out from here and created a separate class to put it in. So now if we want, we can make the student list an array list. We can make it a linked list internally. It's really up to us what we want to do with it. So we just sort of move that to a different level. And now I can run this and we can see our code still runs. So that's great. We didn't break anything. Now here's where we're going to do something that's kind of cool in a really handy, helpful way, which is our understanding, here it is, of, oops, why did I close that file? List interface. When we go to this Oracle website, what we can actually see here is that we know which classes implement this interface, and one of them is ArrayList. So we've actually been secretly using this interface, this list interface, through ArrayList already. So what we can do is we can go ahead into our code base here, and in our student list, implement the Java implements list, the Java list class. You're going to make me do that? Or is the problem just that I have to inherit it? Quick fix, import it. That's all it was. Okay, so now we are implementing the list class, which means we are missing some methods here, as we can see. In fact, we're missing a lot of methods. We can do the quick fix and it will make all of those methods for us. Did it work? Add unimplemented methods. And all of the methods that we already get access to, thanks to like an array list, for example, we can now get through student list. Now, since all we've done is make an array list inside of student list, it's simple enough to write the code for each of these. We're just going to call the array list version of each of these. And there are actually other ways around this, but this will be fine. So basically, we just call the array list version of each of these, and it will solve all of these problems. Now, we're not actually using a lot of these methods right now. So this is more of just like an exercise than anything else. Oh, it's just getting mad that it's a raw type. That's fine. We're going to return students dot to array. There is a point to doing this, I swear. Hopefully that we end up seeing the point in a second. It would have been more poignant had I not made this an array list. If I would have made this a linked list or an array, the point I'm trying to make would have been a lot better, but it's fine. It will all work out just fine in my very, very silly way. Return students dot add e. You're gonna be mad about that, aren't you? Yeah, that's what I'm going to fix here. I'm going to have to fix this. This is an object. This is expecting an I student. I can cast it to an I student and we should be good. Same thing I'm going to have to do for this one. Students.remove, cast it to an I student like this. I'm going to have to make sure I show how we could end up with problems with that. I won't forget. Oh, there's so many of these. Okay, I'm not doing the rest of these. I didn't realize how many there were that I was going to have to do. Okay, I'm going to stop. That's enough. Add and remove are going to be enough. Our code still runs just fine because all of these are not being called, so they're not going to throw these exceptions, but they're here so that the compiler doesn't complain. Really what I cared about showing is the methods that I have now already written, which include the adds and the removes. All the others are sort of extras for right now. So this is hardly complete code since I'm leaving a lot of unsupported operation exceptions in here, but it's fine for right now. The main point that I want to be able to drive home here is right here inside of Advisor. Rather than saying student list students, when we declare an object, the data type should, as frequently as possible, be of an interface type rather than the hard-coded type. So I now can make it a list type like this. It won't even care if I have the generics, I don't think, as long as I import list.java. There's a warning. A yellow line is just a warning, but it's fine for right now. I'm not going to worry about the generics of that. And my code is still going to work. Why are you not working? That was a lie. It should have still worked. Oh, clean workspace cache. Okay. That was very bizarre. Let this run. Did it run? What just happened? There we go. That was super bizarre. We can see it still ran exactly the same as before. All we've done is swap out this list, this like student list for list. And we can do that because our student list does implement the list class. Now, the reason that we're doing this is because let's say later on, we want to change the implementation of how these are stored. We want to change it to the built-in Java linked list class. All I have to do is just change that one line. And of course, import it. But that's all I have to do. Because linked list also is implementing this interface and array lists implement this interface, and my brand new student list implements this interface, all the possible ways that this could have been getting used gets covered by declaring it as a list variable. Which means if I want to swap out the implementation to a linked list, to a student list, to an array list, to an abstract sequential list, to an abstract list, to an attribute list, I don't know what all these are, to a role list, to a stack, to a vector, I can switch out any of those instantiations right here, and my code is still going to work. Any of them, because of the forced requirement that comes with implementing the list interface. So that's actually pretty cool and gives us a lot of power and means that our code becomes a lot more reusable. So if later on we decide, okay, we want to be able to have a list of a student list, an undergraduate student list, a graduate student list, an employee list, a staff list, a faculty list, a researcher list, a TA list, whatever it might be, as long as they're implementing the interface list, all of this is reusable. And we have very, very few code changes that we have to make. So that's actually pretty darn cool that that's a thing that we can do. So we did make a student list class. And the nice thing is with student list having its own class is that in addition to doing the basics that we want it to do, we can also then do something extra that array list alone didn't give us. So if this was array list, like it originally was, our code will still run, right? Our code is still, where is it? Oh, it's because I haven't made the import. There we go. This will still run, but I can't really add anything to the array list class methods. If I want to be able to say, I am now, or let me say advisor, the advisor's name. So this person is now advising a new student. Oops, that can't go there. Let's just say I am now advising a new student when they get added to the student list of students that we're advising. When we run our code right now, because we've got the advisor, where is it? Right here, just straight up adding a student to the class, and it's using array list, we're not actually going to be able to do any of that extra stuff. But if instead what we want to do is we want to be able to say, okay, I'm now advising a new student as part of this implementation, we can go to the one that we know is going to get called, which is going to be this one. I can do this. This is for the student list. And now, instead of array list, we make this say a new student list, so our own object. And we get this really awesome extra help. We can add additional implementation when we wrap the array list class in our own class and implement the interface. We can make our own implementations, our own behavioral changes to the methods that we want to run, such as printing out error messages or logging or whatever it is, and make it really, really like just crazy easy to flip between data structures, right? All I have to do is change this one line and I can flip between data structures with no hassle. now that my student list implements the same list class that array list does. So we actually get this really powerful tool of being able to add additional implementation, switch between implementations, and the front end, so like in this case, the console, is none the wiser. It doesn't care. The output doesn't change, but how we're choosing to implement it can totally change. It's very, very helpful. So we just looked at this, right? So Java's collection classes use this strategy. So collections meaning collections of data. So array list and linked list and all those other ones we saw did have a list interface. And we were able to declare our class using the list interface data type and then instantiate our variable as the concrete array list or linked list. And then our program continues to work. And it's not just like preferred. I mean, it's not a programming standard, so I guess it's preferred, but you should try to think about doing this as a requirement. When we declare objects, we should be trying to declare them as their interface type whenever possible, because it just makes our code easier to extend later on. So before we close out our interface segment, we're going to just show how this collections.sort works. And we're just going to do it in like another example here, just to make our lives a little bit easier. We're just going to make a brand new folder that's going to do the collections example. Just for like a simplified example here to show how exactly this is going to work. So we're going to have like still a student.java file, like what we had before, only I guess before we ended up naming it like undergraduate student, but whatever. So here we're going to have a new one that implements comparable. And we're going to be able to compare students. Now I'm going to go ahead and make students have a name and students can have a student number, and that should be sufficient for right now. And then we'll just make a new student, pass in their name, pass in their number. Oh, they can't both just be N. That's super funny. And we can say name equals N and student number equals num. And then of course, we're going to need a toString. Whoops, public, I can type, public string toString. And this will just print out the student's name. And we will put their student number in brackets as we have been doing, just as a nice, quick, easy way to do this. Okay, so that's great. That'll get returned. And now, of course, this still is not going to run. This should be an int. This is still not going to run because we need to now implement the unimplemented methods from our interface. Here's our compare to. We can go ahead and figure out how we're going to do our comparisons here. And we know what we want to do. We want to compare this dot student num to the other student number. And that's going to be good enough for us to do comparisons of students. Now, again, this is something we were already doing before, but when we go over to main now, we make our brand new main and we have our, main here, and we're going to make an array list. Ooh, array list of students, new array list. There we go. We can do something really cool with array lists. So we haven't actually used the collections.sort yet, I'm now realizing. So let me just quickly show how it works with integers. Array list, integers. And we can just say al.add 5, al.add 3. We're just going to add a couple of numbers to our array list here of numbers. 11 and 9. We can print it. And now I just want to show how collections.sort actually works. So I can go ahead and do this, and I can print it again. I just have to import the collections class. Now I'm just going to also print here before sort and after sort, just so that we can actually see collections.sort running. I think that'll just be helpful since we haven't actually seen collections.sort yet. We only talk about writing our own sorting methods. So here we can see before the sort, it's like this, and here it's after the sort. Can't remember what kind of sorting algorithm collections.sort uses, but it's more than sufficient for what we're doing, and we can see that it does put things in sorted order. And it does it by magic, basically. So now if we want to do this again, only this time we want to do it on our students before sort and after sort, we can do it on our students like this. Now we don't have any students yet in our list, so let's go do that first, and then we can see it actually working. Students.add, new student, and every student is going to have a name and some kind of a number associated with them. I'm just going to fill it all in just a second. We'll have Isham, we'll have Mia, and we'll have, oh, these are already going to be in sorted order if I'm not careful, Apurva. And let's give them student number. Oh, I'm not sorting by those. I'm sorting by these. I'm so funny. 4, 5. Then we'll have 1, 1, 1, 1, and we'll have 0, 8. Oh, well, let me start with that. There, 8, 7, 3, 7. 8, 7, 3, 4. Okay. So now when we run this, you'll notice that collections.sort is still fine with this. When we click run, we end up with before sort, Isham, Mia, Apurva, and then after sort, Mia, Apurva, and Isham, because they are going in order of student ID, which is what we went by. Now, just notice that if we pull this out, main complains because collections.sort can no longer do anything with this. The method sort in the type collections is not applicable for this object. All the elements in the list, right down here, all the elements in the list must implement the comparable interface. So when we added this, we got this super awesome ability that we didn't have before to call collections.sort, and it will use our compare to method to do the sorting for us. Way easier than writing our own sorting mechanisms like we did a couple weeks ago. Okay, so that's the last piece I have on sort of the basics of using and implementing interfaces. The next set of videos is on abstract data types, and they are going to continue the conversation about interfaces and ways to use them to create new data types, similar to what we saw with like student list, but a little bit more formalized. That will be the last topic of the course, other than doing the last practical topic, I should say, of the course. And then we're going to do a little bit of theory. And then you made it to the end. So thanks, everyone. I will see you over at the next video.